underwater. And so what I want you to think about throughout the remainder of this talk is, even though we don't know that much about this system, why? Why don't we know that much about this system? Is it because it's hard to get to, or is it because we don't care? And I think those are two totally different things that we need to start acknowledging. So, moving on, training citizen scientists. So again, our bread and butter is going out and collecting the data, but we have amazing people who come out and do it with us. So we do annual trainings and recertifications. So every year, I actually have one this weekend in Humboldt. Every year we go up and we're like, hey, 2 weekends, give me 2 weekends of your time and you will get Reef Check certified. And what we do is folks come in and over the course of a weekend, we do a lecture. I teach them how to identify species underwater, how to do the data collection, how to be an ocean steward. We go in the pool, and then the following weekend, so June 8 and 9, folks are coming down here, and you'll probably see us on the beach, and we go and we do our checkout dives. And so that is the Reef Check course. Recertifications, every year that divers have already been out in the water, we have to recalibrate them. We need to make sure that they're still collecting good data. So that's what we do as well. And lastly, after we do these trainings and recertifications, we actually continue to survey all year round. And by year round, I mean summer in the North Coast, because that's how much time we have before the winter storms come. So basically, we work from about May until the end of October-ish, but I try to get us out of the water by early September. So that's kind of what our summer looks like. And as of 2018, we've trained a total of 1,592 divers in this program. So that includes a number of individuals who have independently come to us to get certified, but also this includes academic and institutional partners. So places like the Monterey Bay Aquarium and Cal Academy and a number of different universities. So for the universities, this is often the first chance that marine biology students majoring in marine biology have a chance to go out and do science in the water. And so we're that first experience for them. And so it's a really great gateway for a lot of students, but also, again, focusing on the public. And collaboration. Just so you know, we're not the only ones collecting data. I mentioned the Department of Fish and Wildlife collects a number of different data, but within each of our regions in California, we partner with an institution. So mine is Humboldt State University. And I work with that group of folks very closely. And so what happens is the state gives us a number of sites that we want to hit. And our goal here is to go to as many of these sites as we can possibly hit in the summer. And my job is to coordinate that with these programs to make sure that happens. And that happens throughout the state. And lastly, outreach. Thank you for having me. This is what I'm talking about, the interest that we're seeing here, and for you all to be here, I really appreciate it, and it tells me that you care about something we're going to talk about today. All right, so monitoring efforts and ecological history. So how do we actually collect the data? I won't get too deep in the details, but we survey a range of 5 to 18 meters. So that 18 meters is about the deepest depth that kelp can grow at, given light and cold, temperature and things like that. Oops. Transect area, so we survey 30 meters long, so each one of these is 30 meters and 2 meters wide. So mine is about wingspan out here, wingspan out here, and that is the area that we go out and we survey. And in that time, we're also looking at those 73 indicator species I talked about earlier. And we have a little bit of data. So again, I mentioned we're an international NGO, and so the idea is that not only is the public involved in collecting the data, but it's also accessible to them. So any one of you can go on our website and say, hey, I'm interested in Northern California, and you can actually select the region, you can select a specific site, but you can also select a species. So if you were interested in abalone at Van Dam in 2009, you could go find that and download that data. So that's a really valuable tool for the public to also have an insight on what kind of data is being collected. And so this data is also, like I mentioned, international, but if you just want to think about how many of the sites in California we hit, we've been continuing to increase the number of sites we hit, especially here in the North Coast. And today I'm going to be talking about the North Coast, and when I say North Coast, I'm talking about this region, excluding Humboldt and Brookings, Oregon area. So, site expansion in Mendocino and Sonoma County. So, in 2007, there was no regional manager. This position opened up in 2014. So, up until then, folks were working out of the Bay Area and driving up here and doing that whole song and dance. So, we only had 7 sites around that time. In 2014, because of the designation of the marine protected areas, we started to increase the number of sites that we were able to go to. But it wasn't until last year and how much things have changed up here that we decided that there was a sense of urgency. And so we doubled the amount of sites that we have here in the North Coast to increase that resolution and to say something about not only what's happening at a regional scale, but at these very particular places. Because as we know, kelp forests are very patchy and very dynamic, and they change from cove to cove and forest to forest. So the idea is that more data will give us a better understanding of what's happening out here. And so why did we go out and do all these things? Changes. So there were a massive amount of changes that started happening up here in the North Coast, and that's really what prompted us to increase the amount of sites that we go to. So how many of you have read about something happening to our kelp forest in the paper? Yeah, it's been covered very well. Thank you, Michelle. And so it's been a pretty high focus for a lot of folks in the news is talking about what we're seeing out here, which is incredibly, incredibly important, is talking about this not only at a very localized scale, but a regional scale. And so today I'm going to talk about some of those changes and why we're reading so much about what's happening out here. So first off, is it hot in here? Maybe. So, you know, we can say what we want about climate change and environmental things that are happening in our ocean. But what I really want to focus on is why that could possibly be. So if you think about heat gets trapped in our atmosphere and creates pressure. Pressure is energy, right? So you can think about if you got a thing of coffee, right, with that little lid that pops off, and you shook it, what happens to your lid, right? And that's pressure. That's water vapor. That's energy. That same sort of idea applies to the ocean. So when you're increasing the amount of heat, that's increasing the amount of energy that is now trapped in our atmosphere. And that energy can transcend into waves, into storms, into swells. And so that heat is definitely fuel for these storms. Another big change that we've been seeing up here are the warm blob that appeared. So how many of you have heard of the warm blob? Yeah. See, everyone in the North Coast is in tune with what's happening. So there's this warm blob that came here in about 2015, and that blob itself persisted. And so if you look at the temperature, it's not a great deal warmer, but to things in the ocean, it's a big difference. Temperature is a cue, right? It tells things when to start budding. It tells things when to start releasing its spores. So that above normal warm water definitely had an effect on some of the things that we have up here. Another big change that we had was an El Nino period, and one that persisted in a varying level of frequency and magnitude, as opposed to other storms like the 97-98 or 82-83 El Nino. But the one that we've been experiencing up here has been pretty persistent. I actually did my master's thesis on storm energy on kelp forests, and so something I was really interested in is how can we even magnify or say one storm is stronger than the other? The one that we were experiencing started in 2015 and has been kind of trickling ever since. So stay tuned on that one. But in addition to these oceanographic changes that I've kind of been focusing on, I kind of want to go back and think about some of the biological changes we've been experiencing. So not only have we been experiencing oceanographic changes, but this region particularly has been hit by a number of biological changes. One was the loss of an urchin predator, and their very first urchin predator, which was the sea otter. So in the late 1700s, mid 1800s, the Russian fur traders, along with American and British, trickled down the coast of the eastern Pacific, Alaska, etc., and made its way down here and had a base in Fort Ross there in Sonoma County. And so what happened in that time was, in about a 40-year period, all the otters were taken out of that system. So when you think about losing a top predator, what happens when you remove the wolf from the forest? What happens to the deer? Yeah. So what's interesting is we didn't necessarily see that shift happen visibly that we could see, right? And given the limitations of diving and not being able to see these things until a much later time, much later than these individuals were taken out. But we didn't really start seeing a lot of changes until we lost our second predator, which was in fact the sea star. So in 2014, how many of you heard of sea star wasting? Yes. So sea star wasting hit 2014. A Denza virus swept through the entire eastern Pacific and took out a ton, and by a ton I mean over 90% of our sea star populations, and most importantly, the predatory sea star, which is the sunflower star.
Yeah.
So the sunflower star got taken out. So with the loss of that final predator, what did we start seeing? Big changes. Big changes. And so some of those changes included, I'm sure this vision is very vivid for all of you because you've lived here and you've seen this yourself. But we had kelp forests, and then, that year and a couple years later, we start seeing urchins coming through and just taking out this understory kelp, along with, you can see this is articulated coralline, until you'd see these sorts of images where you'd have these complete blankets of urchin barrens covering the bottom of the ocean. And so we call that a phase shift. It shifts from what was a kelp forest ecosystem into an alternate but stable state. And so that's a buzzword. If you hear alternate stable state, that's what that means is life can live in this state, right? Don't get us wrong, but that's not the kelp forest that we once knew. So just know that those are two states that can persist. So what I want to talk about, though, is the numbers. So this is what we saw, right? So we're collecting long-term data. Let me just orient you real quick. On the x-axis here is time, so 2007, 2018. On the y-axis, on this side, is sunflower star, so that predatory sea star. And note the density. So we're talking the number of these individuals in that 60 meter by 2 meter area. So if you swam in that entire area, this is on average what you would typically see up here. So it used to be about here with a little bit of variation. However, we saw a pretty slow decrease until a complete drop to 0 in 2014, and that was the onset of the sea star wasting. Looking at purple urchins, again, you're following that trend at or near 0 for most years. Until 2013 to 2014, we saw a little bump with the loss of that predator, and then pretty much doubling up into close to 1,000 individuals in a 60-meter area. So a pretty sharp increase in the number of grazers in this system. And so with these grazers, more mouths to feed. Basically what we're seeing here is that same purple urchin density, same thing again, but what I'm showing you now are bull kelp, which is, again, that big tall kelp, and that's in yellow, and then pterogophora, which is like the bushes of underwater, and that's right there. And so what we're seeing, again, is as soon as those purple urchins show up, it's all toast. Everything drops to about 0. And actually, since we're in Fort Bragg, that little blip that you're seeing right there is an artifact of one of the sites that we established last year, which was Portuguese Beach. So many of you, I'm sure, had driven by Portuguese Beach last summer, and there's a pretty solid standing stock of bull kelp out there. So that drove a lot of the kelp that we saw in that year. And then lastly, there was nothing left to eat. So with all those purple urchin mouths to feed, unfortunately the red abalone was just less of a competitor, not as good at getting food, not as good at reproducing, and not as good at holding space the way that urchins were able to at that time. So what we're looking at again is thyme, bull kelp in yellow, same graph as before, but red abalone. What we're seeing is holding pretty strong here until about 2013, and then you're like, boom, and you're like, what is that about? Like, Tristan, we're talking about abalone disappearing. Why is that happening? Any ideas? Divers? Because that puzzled me at first, real hard. Yeah.
They're going down further to a different depth.
Ooh, who they?
They, the abalone.
Yes, but the opposite. They went shallower.
They went shallower. Okay.
Yes. So actually, this was a behavioral change. So, what we ended up seeing was in 2013 to 2014, for those of you in the water, the urchins had started moving through the kelp forest by this time. They had already shown up in about 4 to 5 centimeter sizes, which means that they were already somewhat adults when they showed up into our kelp forest. And so what that means is they were able to eat really well and really fast and mow through and get to a reproductive standing point. And so what we saw here was them mow through the kelp forest. In 2014, abalone started coming out from their cracks like, where's my food? Because usually I just sit here and it shows up. And usually that's what would happen, but they had to actually actively start feeding. And so this behavioral change is what we saw as an increase. So they moved from deeper waters into shallower waters looking for food sources. And so unfortunately what that caused was a precipitous decrease over time as well. So although they did increase at that one point, they continued to decrease as they moved into shallower waters and began starving while looking for food. And so I get a lot of questions also about differences between Mendocino and Sonoma County. Like maybe you've heard like Sonoma's way worse off than we are. For the most part, that's true. But I just want to show you what that looks like. So here you're seeing Mendocino and then Sonoma. 2017 is green, 2018 is yellow. Again, that density, same thing, 60 meters squared. This is red abalone. So between 2017 to 2018, in both counties, we saw a slight decrease in those numbers. For bull kelp, I found this very interesting, that you pretty much have nothing going on in 2017. But 2018, up here, we got a decent amount of kelp, huge variance, right? So those bars mean it's very different between each of the sites that we go to. That's what those bars mean. So bigger bars mean bigger differences in those places. Short bars, less difference. So that's kind of what we were seeing in Mendo, but Sonoma was pretty dismal, nothing really going on right there. And then lastly, purple urchins. This I found interesting as well. Still high in both places, right? At face value, that's still a ton of urchins, but we had a slight decrease in our county in 2018, but then a slight increase in Sonoma. So this year will be pretty telling on what each of those places are doing. And so just to recap, I see a lot of sad people out there, and it's not sad. We'll get to what we can do. But just to recap what I just talked about, there are a lot of things affecting our ecosystem. It's not one thing. I think it was John Muir who said, if you try and take one star out of the galaxy, you'll realize it's attached to everything. Everything that we do has some kind of consequence. And so a lot of things added to this problem that we're now facing. But ultimately, we saw declines in sunflower stars, bull kelp, pterogophora, and red abalone, but unfortunately an increase in purple urchin densities. And again, we were able to double the amount of sites that we were visiting between 2017 and 18 to again paint a better picture and idea of what's happening here. But what I really want to talk about too is that we're not the only community facing this, and we shouldn't feel that way either. All these red dots, and actually I'm gonna read you the name of them. Oh, I have to enter my password, no I'm not. So, in all these red dots, all these places, those are places where they've experienced a phase shift. So again, moving from a kelp forest to an urchin barren. Some of these places have experienced a reverse shift, where they go back to a kelp forest from an urchin barren. Some persist as urchin barrens for decades. Some persist for centuries. We don't know, because the time scale to which we've been scuba diving is quite short on the grand scale of time. But what we do know off Middens in Alaska and the Aleutian Islands up here is that a lot of these places did in fact experience this back to around the time of the BCs, right before BC. So there is a possibility that what we're experiencing is a blip in time and that the ecosystem will self-correct. But I also want to point out that as we're moving forward and talking about what this actually means for our community, that we think about us not being the only ones dealing with this, but we can learn some things from the other places that have experienced these changes. So whether we find out how their businesses survived, how the people found jobs, those sorts of conversations can be had at that kind of larger scale. Some other good news, the warm blob that we were talking about may have relaxed. And so I saw this in the Advocate a couple months ago, but it was pretty cool. You see that warm blob and then it just kind of dissipates. So that's some good news that's changing a little bit. Yeah.
It's warming up again. It's gone
Is it
up.
warming up again?
Since February, it's gone up 5 degrees.
Has it gone up? At that scale?
Yeah.
Ooh, that's
Very
interesting.
scary.
Because we've been experiencing like cold waters too,
Yeah.
but close to shore. So that's interesting. I'll look into that. Thank you.
Well, one other thing
Yeah.
that I'll tell everybody right now is that yesterday somebody walked on 10 Mile Beach and found 50 dead common murres. And then Sarah Grams did it today and found 65 dead common murres. So something's going on in the ocean.
Yeah.
And we're scared.
Yeah. We should talk later. We've
Yeah.
seen some things. We'll talk. So yeah, that's really good to know, and that these things are changing. What I found interesting too, though, is remember those winds we were getting a couple weeks ago? The temperature dropped 7 degrees between like a 1 week period in Van Dam. So I thought that was pretty impressive and told me like upwelling may be kicking off. But
Did you say 7?
7 degree drop, yeah. So we were at, what was it called, like 52?
Yeah,
And
something like that, and then down to 45.
Yeah, so it got pretty cold in a very short amount of time. No one told us until we got in the water, like what happened? This is insane. Okay, so moving on, it may have relaxed, may not have, we'll keep you posted. We'll find out from the Advocate soon enough. But what that cold water means is, again, the timing of kelps. Kelp love cold water. Cold water holds a lot more oxygen in it, and it also makes nutrients more available. So something interesting I found in San Diego, for example, is if the water temperature hits 15 degrees Celsius, kelp can no longer absorb nutrients out of the water. And that's the giant kelp that you see. So there are certain temperature cues that can inhibit kelp from actually hitting it off. So just keep that in mind with temperatures that you're seeing. And lastly, what we can do. How am I doing on time?
You're fine.
Am I okay? Okay. Okay, I saw this today. I don't know if it just really kind of hit me because it kind of encapsulated what I feel most days, where you kind of wish that you can go above and beyond and rescue the turtle from the net, but at the end of the day, we come to events like this. We go, we pick up trash. We go, we walk the beaches, and we make observations. We also build whale skeletons, and we also create an amazing space for kids to come and make these amazing visuals. And so I think what that really means for us is that although you feel sometimes that you're not doing enough, just doing what you're doing right now is more than what a lot of folks are doing. And so I encourage you and thank you all for doing what you're already doing. And so I just wanted to let you know what we're up to. So what I'm going to do moving forward with our other partners is process oceanographic data. I didn't talk about it for my previous slide, but we also have oceanographic sensors out. One in Van Dam and the other in Point Arena. Point Arena being the wave energy, and then Van Dam being the calm one. But the idea is that we have a pH meter, dissolved oxygen and temperature, and that unit measures year-round. And so we're getting real-time oceanographic data from our region that is pretty hard to survey. So that's happening, and those are deployed throughout the state as well. We also have over 70 temperature loggers deployed throughout the state as well. I'm also going to continue this summer to expand our abalone and urchin size frequency data set. So a lot of you may know that they're revisiting the abalone fishery management plan. One of the ideas is that they start collecting more size-specific data on those individuals, so we're helping with that. And then lastly, we're making it a priority to continue to provide the best readily available data to the state to make well-informed ecosystem-based management decisions. What you can do is talk about what you learned here today. Knowledge is power, and stay vocal. So everything I just said, just keep doing what you're doing, keep learning, and talk about what you see and what it means to your community. Report washed up sea critters and observations. So over the winter, we got those pretty big swell events that were happening. We brought up that abalone have changed their behavior, so they've moved into shallower waters. What happens when storms hit shallow waters? Yeah. And so something we were worried about was that abalone were kind of getting the brunt of that. So what we started doing was walking beaches and starting to count the number of abalone we saw on the beach. Not only as they are whole, but we noticed that there were cracks in them, like they had been destroyed by wave energy. So if you do walk beaches, which I think most of you do, and you happen to see things out, I'm interested. I have a running log going where I have your observations. You can take photos and send them to me. I have that going too. And so I just want to make sure that if we do see something up here, that it's being recorded and documented. And lastly, make a donation to support our endeavors here on the North Coast. And I'm not talking financial, I want your time. And so whatever you can donate, the Noyo Center, donate your time to these organizations. That's what we really need to get these projects off the ground and get them to their uppest potential. So thank you again for all that you do. And so one last thing, I made this morning, but if we're talking local, if you're here in town and you're interested in helping, I already made the answer for you, it's yes. But are you a scuba diver? Yes and no. So if you are a scuba diver, come see me. If not, Sheila's right there and we're in this beautiful space. But I think something else that we need to think about is what we do in our day jobs that might be helpful for these organizations. So both of our organizations, I'm sure Sheila could say that too, is that we need your skills. All of you come from such a diverse background, engineers, construction workers, doctors, you name it, I've had those volunteers. And so your skills outside of your ability to also be a biologist and citizen scientist is hugely helpful for our organizations. And so I encourage you, even if you feel like you have nothing to contribute, you do. One particularly that I put up front there is Real Estate Magazine, Zita Borsch. I was walking through the Cipino dinner and my mom was with me and she was like, come meet Zita, and we started talking and then she was interested in kelp forests and so we started talking more and then she ended up writing this article and we did it together and there's some up front there. Grab one if you haven't read it yet, it's exciting. But just things that you wouldn't think are really helpful, this has made its way around the entire state. And so getting people to know what's happening here on the North Coast gets us in that bigger conversation and it gets us a seat at the table. So continue to use your skills to talk about things that really matter here in our community. Your skills and mind are valuable, so put them to work. I don't see any students. Hey there, I see you. No, I'm some student. You're a student? All right then. Yeah, for the students that I usually have in the talk, I just tell them to take that opportunity. Maybe you can tell this to the folks you're involved in, or kids, grandkids. Tell them to take the opportunity. Get the experience in something that is other than school, so talking to people who are other than school kids also. Do a senior thesis and have it as interdisciplinary as possible. And interdisciplinary just means pulling together a bunch of different fields and making it something unique to what you need. And then lastly, be reliable and follow up. For those of you interested, we still have 2 classes being offered, one this weekend, and then this one here in Fort Bragg. If you're interested in sitting in on the talking component of this, come talk to me after the class. And lastly, I just want to thank all the divers who collected all of this data since 2007. And I had the pleasure of having these 3 beautiful interns this summer. One who came from Humboldt State, and she's a substitute teacher, and also in Humboldt State, and then CSUMB. But we also accept dive specialist interns here in the North Coast. That's a program I've been really trying to get moving. So again, if you know someone interested in that, let me know. And I will take any questions.
Tristan, I wanted to ask you, I know they have this purple, they have that collection program with they're collecting purple urchins. Has that been able to make any difference? Can you replant kelp if it disappears? Can you replant it?
I'm going to let Sheila answer your first question, and I'm going to answer your second question about kelp, because I love kelp. I'm not letting Sheila have my kelp. Take their kelp.
Yes, so
Yeah,
to
go ahead.
answer the first part of that question, we are actually still working on this program called Help the Kelp, and Tristan does a lot of the ecosystem survey work as part of that program. The Noyo Center contracts commercial divers. We removed purple urchin from the environment. We took out over 1.2 million urchin last year, or over 40 metric tons, in 3 spots in Casper, Noyo, and Albion. Both commercial divers and rec divers together also take some urchin out. Now, this year is going to be the critical year, especially for what Tristan is talking about, because we need to go see if we get a succession of kelp regrowth in those areas. So it's an annual species, so we have to wait until this time of the year to see if it starts to regrow. It's one of the fastest growing species, so it grows, its height in just a few months. So you could talk about planting or not planting.
Thanks for not taking.
But we do need, the reason why we did the areas we did is because there was existing stands of kelp that could be that spore bank for our oasis zones.
Well, did the urchin move back into the sites that have been documented up?
Yeah, that's a great question. So what was an unfortunate thing for the program was we got out of the water in September around, and then the waters got huge, and we didn't get back in for 6 months. We didn't really get back in to look at the site, so we were all a little bit nervous. And the initial feedback from the divers is it hasn't been really reinvaded badly, like maybe about 15%. So in that long period, hopefully we won't have to go that long again without maintaining it. We need money for this program, so we're actively out fundraising for the diver component, and so right now we're just sort of maintaining those areas we cleared last year and trying to document if we can get kelp to come back. And if we can't get kelp to come back, then we have to look at manipulating the environment a little bit more. That leads to your second one.
And that's actually, that's another piece. I didn't really talk about that facet of what we do either, but our job in that Kelper partnership is to go out and provide that baseline data for all those places that we've been surveying over time. But last year we also put new sites in where these urchin removal efforts were happening. So we put a new site in at Noyo Harbor and a new site at Albion, so that we were able to document the before urchin removals and the after. So stay tuned on that data because we haven't been back out there yet, but will this summer. But I want to answer your question about seeding. Yes, you can. So basically, remember how I was talking about everything happening at the sporophylls at the very top of the kelp? So does reproduction. And so what you can actually do, and they've found this in a few different places, is you can cut those when they're reproductive, so you can tell because they have this like milky bit in the middle. That is still good to go. Those can actually drift through the ocean for days, and they can still drop spores. Red algae has been known to travel thousands of miles and be dropping spores the whole time. So yeah, they're pretty robust, and it's because they're these like little seed packets. So yes, they can be seeded, and you can even like zip tie them on a rock, and the idea is that they will self-propagate. Yes?
When you do have to reseed, have you done that yet?
No, our group isn't involved in any of that seeding.
Yeah.
I'm sorry. It's sad.
So just so to be clear, so hopefully we're gonna see a natural recovery from the
Yeah.
existing spore bank that's there, because what we want is that genetic diversity.
That's what I was gonna ask.
Right, so that's one of the big questions. If we actually put a blade of kelp down in the environment, we don't have that diversity. So that is sort of the next step, if we aren't seeing. But you can understand that with an annual species, if the purple urchin come and mow down that kelp before it gets to that reproductive stage, there are not spores in the environment. So protecting that spore bank is really one of the key goals of the partnership that we're working on together.
Exactly.
When does the kelp come viable for dropping spores? What time of year?
Depends. So the question was when do they start becoming reproductively viable, right? That can start as early as June. We've seen it in some places. It depends on environmental factors, but as late as November, I've seen it up here.
It's fallish.
Yeah, it's fallish. It has this pretty wide range, but it's really kicking off in like August, September, right before the storms pick up. I'm gonna go here. Yeah.
Do you know of any other organizations that are removing urchin, kind of like we're doing the help in this region?
Yes.
You want me to-
Yeah, go for it. Yeah.
So Tristan showed that slide of the world and all of the places where urchin barrens are forming. Many of those places have programs where they're removing urchin. In fact, we're trying to unite those projects right now under a global partnership. But in California, for instance, there's a kelp recovery program going on Santa Monica Bay with Bay Foundation, and they are removing purple urchin. They have a different type of giant kelp. It's called Macrocystis. It's a perennial species, and so they have a really different system. And so the reasons for kelp, for urchin barrens forming in all these different places are different. But what we're learning about recovery is information that we can share with each other. So we're working now pretty closely with the Bay Foundation and the other folks in Southern California who are removing urchin to see what we can learn from each other. They actually had a wasting syndrome in their urchin population. So they had a little bit of a leg up from the environmental conditions than we do. Of course, we have a super hardy purple urchin. So they were able to remove urchin from the environment and within a year see a healthy kelp forest come back. So I think this system is super resilient if we can give it half a chance.
In the back.
Are your monitoring activities revealing any signs of resurgence in any of the sea star population or that species?
Yes, not for the sunflower star unfortunately yet, but we have seen slight increases in ochre stars, so also urchin predators, and those have actually moved somewhat from the intertidal into subtidal deaths also. So we've seen those ochre stars. We've also seen leather stars, which are also known to eat purple urchins as well, which is encouraging, right? Because a lot of the behavioral changes we think that we saw from the urchins may not have been necessarily because some predator comes and eats them. It could simply be because of olfactory scent, right? What happens when you sniff and all of a sudden you don't smell your predator? You could move in safely, right? So having those sea stars even come back at that scale, pretty happy about. Yeah, in the back.
Yeah, I had a question. We visited a place in Kona where they're reintroducing a seahorse back into the water. And do they have a breeding program for the starfish in a lab environment where they can breed them and then reintroduce as the kelp comes back?
Yeah, so one group that I know of is Western Washington University. Do you know of any others doing that? Last time I checked, they were trying. The major limitations of restocking those sea stars is because the Denza virus, the sea star wasting virus, is actually still in the system. So Colin and I, when we go out, we actually still see wasting happening. Not at the scale to which we saw it back in 2014, but it's still in the system, which is kind of worrying. But from what I've heard about, they haven't been able to successfully do that yet. But some areas, like in British Columbia, have held on to some of their sunflower stars also. So they're not completely extinct or anything like that. Yes.
What happens to the urchins that you remove?
So we don't remove, do you want to talk about what
Yeah.
happens to urchins? Yeah, I'm so happy you're here.
We're so that's why we work in a partnership.
Yeah.
They find homes
So
for all of them.
this past year, the urchin that we removed were composted by Cold Creek Compost. So you can't just throw them away if you remove something from marine environment. You have to make a productive use. So this is kind of a unique situation, and so, you know, turning them into compost is great. But one of the keys to the program is to figure out how we can either build a new fishery or find some use that will incentivize the take of purple urchin. So one of the things I will give you a brief update about is an aquaculture pilot test that we're doing to take those empty urchin out of the environment, fatten them up on land, and sell them for seafood. So I'll give you a little bit of an update on that.
Yes.
Yeah, I'm curious, how long are the kelp spores viable for, and where do they go in the environment?
Great question. So the question was, how long are they
Viable.
viable?
How many years, or is it just an annual thing that they can survive in the
Yeah.
environment, and where are they in the ocean?
Yeah, so let me go to a picture of kelp real quick. Not my dog. Do I not have any kelp here? Okay. So right here where the spores hang out, bull kelp is an annual species like Sheila mentioned, so once a year it's going to produce spores that are viable, so only once a year. The other kelps like macrocystis, multiple times per year it can be seeding off. What happens to these? From what I've read, bull kelp actually have pretty dense and heavy spores, so they've been known to drop like relatively close to where they are, but it totally depends on what the ocean decides with current and where it goes, etc. There was actually, before this, I worked a little bit on a project. I was looking at the connectivity or the relatedness of individuals based on how far they were from each other. But for bull kelp, we do know that they do seed relatively close to where they are. And then, what was your other?
How long do
How
the
long?
spores live?
So the spores, after they've dropped off, they can actually attach themselves to rocks. And so that's what Sheila is also saying is, once these spores drop, they're hanging out like on the tip of a rock, right? And so protecting that space is really important because urchin grazers can actually mow through and eat those microscopic spores also, because those stay fixed until the following year when they're ready to start growing again. So in this circumstance, which is the ultimate paradigm, on the abalone shell, but the spore hit on this ab shell and just took off. And so it really depends on the spore finding a clean place to drop and not getting eaten.
So can the spore itself, if it doesn't get eaten by an urchin,
I believe-
5 years?
That's a great question. I don't know. Do you know?
Well, so, you know, we just went through a whole year process of kind of looking at what do we know, what's the state of the science? And that was actually a great question that was debated, and something that we don't really know. And so if you can imagine a situation where a reproductive frond loses its spores in a normal environment, it might settle out under some kelp or, under an abalone shell that's dead, and it doesn't get light, and it doesn't trigger its growth in the spring, right? So they think that there's some theories that can be a decade or more, that they can stay under cover in some way. But what's frightening about what we're seeing right now, what's unique about what we're seeing right now, is this explosion of urchins, 60 times or more than is normally in the environment, is not only eating the kelp, but it's actually, once it's done with the kelp, it starts grazing on other things. It's a very opportunistic feeder. And it's starting to eat the crusting coralline algae, and it's starting to eat the rocks, and it's starting to eat the outer parts of the abalone shell, it's starting to eat the meat of the abalone shell. So they're now wondering if it's eating the spores. So now we see a high percentage of bare rock instead of seeing all the different versions of smaller algal species on the bottom of the seafloor. Now we're seeing a super high percentage of bare rock. Leslie, do you have a better answer to this?
I don't know about the lifespan of the spores. That's not something the people have ever contemplated, because there are always plenty of spores.
Right.
And, you know, each year, so many would germinate and grow. So I think that's a new question.
It is a relatively new question, yeah. And again, we know a lot more about macrocystis than we know about neurocystis. So bull kelp is very poorly understood as a species. So that's another reason why it's really important that we keep this research program component to removing. We're not just removing purple urchin, but we're trying to understand the dynamic between the urchin and the kelp and the environment.
And how about the shorebird species that we rely on? The migrating birds as well as the birds that come here to breed?
Everything. There's a question in the back, yeah.
Well, my question goes back a few minutes ago. I'm just curious if we know why the sea stars were taken out by this virus and why the virus was so prevalent. Could it have something to do with the temperature of the water?
They think that's one reason that may have triggered it. So this virus is actually found in a lot of different echinoderms. So anything that has 5 radial rays. So we saw like urchins getting a certain form of disease. We saw sea stars. Why that happened, they're still trying to figure out. Did you have an anecdote?
Did the sea cucumbers also have a withering?
You know, we didn't see a drop in their densities by any means. They're still prevalent.
That's one of the few things the fishermen are still actually.
Yeah, that they're still able to fish is the cucumbers. They're still kicking. But they still don't know exactly why it set off the way that it did, but they do know that temperature didn't hurt. And one of the reasons why it must be so widespread is they've been talking lately about how did it spread throughout the Eastern Pacific so quickly, so rapidly, and across everywhere. And one idea, there were a bunch of theories and still are a bunch of theories, but one was birds. Birds may have been able to fly from one area in Mexico up through BC. Birds may be a vector of disease. That's a theory. Another theory I've heard is the warm water allowed it to persist in the water, and as the currents moved, they saw that. But there are lots of holes in those because they also saw a lot of patchiness and recovery of sea stars statewide and also regionally. So to answer your question, they don't have the answer yet.
Yeah.
But those are some ideas. Leslie.
So I just want to mention that one of the things that people have talked about is, well, let's bring sea otters back up here. But the sea otters aren't going to eat these urchins. These urchins are mostly empty inside, which is part of this, program to fatten them up, which they don't actually get fatter, but they grow gonads inside.
Also, the otters do.
Well, they eat abalone, they eat,
They need it to.
yeah, they eat the kelp, yes. Yeah, and the kelp's not there. They don't eat the kelp, but they need the kelp. I'm wondering for the sea stars as well, as we're seeing the ochre stars come back and the leather stars, if these urchins, which, the ones that we break open when we're looking at the urchins that are brought in by the divers, we crack them open. Well, Susan takes photographs of them and sends them off to Cynthia Catton at the Bodega lab. And they're mostly not a lot inside, but purple urchins are more seasonal in their gonad production. So I'm just wondering if these leather stars and Peisaster are finding enough food, or if they're going to be able to knock back the urchin population, if urchins aren't really a very good food source for them because there's no nutrition inside.
Great question.
Do you know?
Sea stars have an ability to eat a bunch of different things, which is also pretty great for them. But unfortunately, urchins have eaten a lot of those other food options, which is a real bummer. But we have seen, like the sea stars that we have been seeing have been, about this size, which means they found something to eat up until that time. The previous sea star had the ability had enough materials to make that baby to begin with. So it's starting to tell us that they're getting food from somewhere. They're eating something to stay. persistent. But last summer was actually we just added ochre star to our data sheet because that species has just started moving into subtidal waters. And so that's another thing on our radar too, is as changes are happening behaviorally, also can we capture it? So that'll be a question that I'll see this summer is, did the ochre stars we saw last year, did they stay? Did they survive? Did they have enough food to eat? Data
Can I
next year.
answer that?
Yeah.
So I asked Cynthia that very question actually, because I was walking the beaches and I started to notice the ochre sea stars were huge. Have you noticed on the intertidal that you've seen really big ochre sea stars? And so I said, does that mean they're eating, because there's a ton of urchin. I said, does that mean they're eating some of the urchin? She's like, sadly, no. That probably means they're not going to eat the empty urchin, like Leslie said. That probably means they're eating the abalone right now, because the abalone are all in the intertidal as well. So that's a,
There's that.
that's a little sad double hit right there. But,
And they're
But-
eating mussels.
and they're eating some mussels. They're like,
Yeah.
you know, they can eat a lot of other things, but yeah, and sadly, I think they're not really that interested in the urchin at the moment.
Right. Yes.
What are conditions like where the otters are present and have been present down
Great
in
question.
Monterey? What is it like down there?
Great question. Down in Monterey, they experienced a lot of what we experienced. They saw urchin barrens forming. They have urchin barrens, even with otters present. Otters, as many of us know, have different dietary preferences. Some are urchin eaters, some are mussel eaters, not really, but others eat abalone. They can have a whole suite of dietary preferences. One student out of Santa Cruz is actually looking at just that to see, you know, of the entire otter population, what percentage are actually specializing on urchins. And that's actually like I don't know if he has like the data out yet, but it's a pretty, not insignificant chunk, but it's not as much of the population of otters. So their ability to act as a top predator in that particular system, questionable. But if you go back to the history of that Monterey Bay area, they've experienced a shift from kelp forest to urchin barren back in the 60s, kelp forest to urchin barren. They've gone into these multiple states, and last year they had pretty heavy urchin barrens, year before pretty heavy urchin barrens. This year they're starting to see a shift actually from macrocystis, so that giant kelp, into a bull kelp system, which they're also wondering like why that is too. So going back to the otter thing, because it was mentioned as well, something I also want to leave you all with is keeping an open mind to the differences in local places. So different systems rely on a different suite of biological characters and players in each of those places. So I kind of have a little bit trouble applying like a one-size-fits-all for the whole otter situation, as I believe each system can respond very differently. So your question about Monterey is very interesting, because a lot of folks were like, hey, we thought this was a top predator, what's happening here? And they're trying to figure that out. They're like, maybe you need a certain density. Maybe it wasn't taught to eat urchins. You know, those are innate behaviors that we necessarily can't manipulate, but maybe those otters can. Yeah, good question. Yes, Leslie.
So I just want to mention a couple of things. One thing that didn't get mentioned. So not only were the abalone kind of pushed up into shallow water, but the red urchins, which is the commercial urchins, were pushed into deeper water and are eating barnacles because there's no kelp for them to eat. So the commercial divers have had to dive deeper, which is not as safe. It's already a dangerous profession. So it's impacting the red urchins as well. And I really love that story in the real estate magazine. You know, a forest is a forest even if it's underwater. You know that if you take a redwood forest down, you lose everything that lives there. So all of the fish, all of everything that's associated with the kelp is impacted. So I want to encourage any of you that want to know more about what's going on out there. You know, if you're not able to get a hold of Tristan, you know, come into the Fish and Wildlife office. I'm happy to talk to people about what's going on, or Jerry, who's the abalone biologist in the office, you know, can share a lot of information about what's happening out there as well. But I mean, what you know is incredible, because you're actually out there looking at it, and it's pretty scary to me, actually. I do want to mention that Con Karpov, who used to work at the Fish and Wildlife Office, said the reason why we have so many abalone on this coast is an artifact of the otters being removed. So when you were talking about, well, we don't know what actually happened because it was underwater and people weren't on scuba way back then, his hypothesis is that there weren't that many abalone until the otters were removed from the system. Yeah.
That's exactly it. Yeah, those are like those lingering things I want you to go home and think about, really. It's like what this means on the scale of time. If you really want to like go deep in it for a minute, just go in the shower and think about time. Yeah, are there any more questions? Yes.
Thinking, time. Ocean pH, it's changing, it looks like it's gonna keep on changing in the same direction for, at this point, a long time. Where does ocean pH play in on this? I mean, it seems it plays in a lot of places, but I'm curious what your take is.
Yeah, so a number of things, right? So if we think globally, what does acidified water mean? What that means is these micro changes in water chemistry. So remember how I talked about like chemical cues and things like using certain signals to reproduce? Some areas go through periods where they have anoxic, so no oxygen in the water, anoxic periods, and then that anoxic water disappears, and then it goes about its life, and that's how those individuals evolved. Some places, especially in the Caribbean, and why we're seeing bleaching, is that those low pH waters come and they're getting bigger and bigger and they stay longer. And so that's some of the issues with acidification. The other issues is that for individuals or organisms that calcify, so create a shell, that shell becomes incredibly thin. So their ability to make that shell becomes more difficult because of the rain constantly coming down on it. It's just trying to harden and just wait for the glue to dry, and you're getting rained on, essentially. So those sorts of processes are deeply affected. Other things that could be playing into what's happening here, we haven't gotten that oceanographic data I was talking about. We don't know necessarily what's happening either with acidified waters locally. So even at that level, we don't know yet. And that's why I think a lot of the research that's stemming right now, like we're living in such an interesting time because we have the beauty of blessing and curse of technology coming in and meeting biologists somewhere right in the middle, and they're accomplishing some pretty incredible things. So I think over the next few years, we'll definitely have some more answers to the acidification question. Yes?
On your ocean temperature map, it showed most of the hot water in the Pacific and mostly in the eastern Pacific.
Yes.
So why the Pacific?
Are you talking about
That one.
this one?
Yeah, that one.
This one? Okay. Were you talking about like this area?
I mean, that's where we see most of the red.
Yeah, so El Nino, this is pretty fun. So El Nino, the reason El Nino happens, or one theory why it happens, trade winds stop. So that gale force wind that's happening here along the equator that's pushing water in this cyclic, basically like trade winds come along here, they circle back, and that is the current that we are getting, is this circling happening around the equator. What happens in the El Nino period is that wind that pushes that water east stops. And so what happens is there's this big pool of warm water over here in the western Pacific, in these really warm areas where corals are. And when that wind stops, that water sloshes slowly over to our side of the coast. And so that's why El Nino is so detrimental, is because you have this really big pocket of water that comes over quite slowly, but also pretty rapidly. And it just kind of stays because those winds stopped. And so that water, because it's warm, also, and because there are no winds, causes our upwelling, so the winds that drive that process, to stop also. So we're not getting any upwelling happening, we just have warm water, and so that's why you see a lot of those like algal blooms happening and denitrified water, things like that. So that's where that like warm pool is happening. Yes.
I just want to mention one thing to everybody. When the California current comes down the coast, it hits Cape Mendocino and gets bumped offshore and is forming an eddy between Point Arena and Cape Mendocino.
That's right.
That's really changing the way our coastal waters are dealing with. We still don't know what's going on. The seabirds that I study are not doing good for the last 3 years. I have a friend who's been studying the ocean temperature and nutrients from the air, and he's documented that this is a problem because we're seeing a different kind of ocean right now than anywhere else and in the old times.
Just when you see, we walk along the beaches and we all see the dead kelp up on the beaches. Should we return it to the water? I mean, you see it just hanging out there after a storm? I mean.
Great question. So kelp, should you replant it in the ocean? My first thought is yes, because you're like, hey, more